My name is Max Arshinov, and for my day job, I'm a CTO at Hightech Group, which is an outsourcing company based in Kazan, Russia. Our main focus is building custom complex systems for our clients, and for the past 3 years, I have been speaking at various conferences, though that's my first time at NDC, and I'm very happy to be a part of it. And for the past 2 years, I also have been teaching at Kazan University. So this is some background information about me. Unfortunately, I don't have a Twitter account, but you can find me on Facebook or email me. So we live in a strange time. Normally, I expect that the audience to share the same room with the speaker. However, this is impossible now. So I tried to take advantage of this new format. My talk includes some live coding. Please feel free to clone the repository if it's more convenient to you to have the code open on your second screen in your favorite IDE. You can also find the presentation and the links and everything that I mentioned during the talk by this link. So, and the last thing before we begin, please text me in Slack or in WebEx chat if there's any where you are now. Hopefully, this knowledge can help us to feel connected to each other, some feedback. For instance, I'm at my office right now in Kazan. Despite that about 1.5 million people live in the city, I don't expect that foreigners know any Russian cities apart from Moscow and maybe St. Petersburg. So here's a clue. I'm only 822 kilos to the east from Moscow. And when I say only, I mean it. Here in Russia, we really consider this a short distance. Anyway, let's get started. So today I'm going to be talking about expression trees. If you had asked me a few years ago if I wanted to know the implementation details of this technology, I would have 100% sure answered no. Because then I thought that expression trees are just part of LINQ. So I didn't expect that there might be some other way to apply them in real-life scenarios, apart from maybe feeding them into queryable extension methods such as select, where, and autobuy. Everything started with just one short refactoring, or more precisely, with something that I thought would be a short refactoring. In reality, it was a starting point down the rabbit hole. I gained the experience on how to properly use expression trees over several years after this incident. We only have about an hour, so I'm not going to tell you the chronology. I will only present you facts, and I will ignore the chronological order. So let's just pretend that you are a random person who just have got a new job as a developer for the e-commerce solution. I will use this example because e-commerce domain is well known, so I hope that business rules will be straightforward to everyone. Every business system has some business rules involved, so let's start with a simple one. Our manager asked us to show on the UI only those products for which is for sale checkbox is selected in the admin area. All other products should be considered as drafts and should not be shown to customers. No problem, we can easily write code like this. So far, so good. After a while, the manager is changing her mind. Is for sale rule still applies, but now she wants to remove products that are not in stock from the UI, because customers kind of get upset when they are told that their products are unavailable after payment and not before it. So this should be an easy fix. Let's introduce another property and call it in stock. And get another one just to combine both conditions into a single read-only property. So that we can encapsulate the filtering rules in a convenient way. Well, and has anyone already guessed what I'm getting at right now? If so, please let me know in the chat. Let's check. Okay, the link works perfect. The link is working. Well, the problem is that this code compiles and perfectly works with in-memory queryables, but it fails in runtime when working with a real DB, unless you have overridden some default ORM behavior. The problem is that the isAvailable property is not mapped to any table column. So ORM doesn't really know which column should be included in the select statement of the SQL query. An easy fix would be to add the toList call just before the where call, but this is not acceptable solution in many cases. We really cannot assume that there are just a few products in the database. There might be thousands or millions of them. So querying them all into memory is not an option. Okay, there is another simple fix. Let's get rid of the isAvailable property and just copy paste the condition as is. This is definitely an easy solution, but what will you do when you have hundreds of lambdas like this? Maintenance of such a code base might be a nightmare. And we all know that repeating yourself is not a good thing, right? So in order to come up with a better solution, we need to examine the basics from the very beginning. Why the same lambda perfectly works when it's applied to an in-memory database and fails with a real one? Have you ever tried to define a lambda function using a var statement? You can't do this because it just won't compile. The C# compiler will ask you to be more specific about whether you would like to define a delegate or an expression. So even these two lambdas look the same, they have different type. So basically, these are different things in terms of the programming language. However, it's not difficult to transform an expression into a delegate. Let's say we have a simple expression like this. To get the corresponding delegate, we only need to call the compile method, which will calmly unwrap the expression and provide you with the instance of the underlying func type. The only disadvantage of this approach is that this is a compilation process, which is synonym with a relatively slow process. Performance considerations might be important to your project or not, but anyway, generally speaking, none of us want random compilations to happen in the app we develop and maintain. So is there a chance that there is an inverse transformation that is faster than the compilation process? The answer is kind of yes and no at the same time. The solution is proposed by another Russian developer. His name is Alexander Zaitsev. His approach is the following. Let's decorate the isAvailable property with a special attribute and add a special decompile method. The implementation of the decompile method is quite tricky. It uses the getIL as a byte array method available as a part of method info type, which is a part of system.reflection namespace. This method behaves exactly as you might expect. It returns byte array of the IL instructions. Under the hood, these bytes are translated into objects using monoreflection. Once we have those objects, we can translate them into expression trees. The decompile method searches for properties marked with computed attribute and replaces the original call of the isAvailable property with its body. This is kind of runtime handwritten inlining mechanism for expressions. Albeit this process is completely unintuitive, this approach might be better in terms of performance in many cases. The bad thing is that Delegate decompiler NuGet package has stuck on version 0.28 and it's not supported. So practically speaking, starting from expression and transforming them into delegates all the way seems to be a much more reliable solution, provided though that performance limitations are not a problem for a project or there is a way to solve them. During this talk, I will only consider the approach when delegates are created from expressions, and expressions are never created from delegates. I'll be using cache to reduce the performance impact. We are good to go up here. Let's review another use case. Some criteria don't have to always be used together. We might want to show products that are for sale or are in stock in different contexts independently. And sometimes we might want to only show the products that satisfy both criteria. So there is an easy way to do it when a predicate is combined using the AND statement. We can just chain multiple var calls together and let query provider do the job. Also, corresponding lambdas can be easily defined as static read-only variables, so we don't have to bother with possible code duplications. But what if I wanted to combine some criteria using the OR operator? I need something like this, and here's the problem. This code won't compile once again, because the OR operator is not defined for the expression func bool type. This scenario is addressed within the scope of the specification pattern. This pattern is explained in the domain-driven design blue book by Eric Evans and is frequently used in the context of domain-driven design. So let's take a closer look. The pattern outlines a business rule that is combinable with other business rules. In this example that we now see on the screen, a unit of business logic inherits its functionality from the abstract composite specification class. The composite specification class has one function called isSatisfyBy that returns a Boolean value. This is kind of authentic implementation from Java world. The usage of this implementation is quite limited because it relies on the isSatisfyBy method, which assumes that all the data is available in memory. You surely can try to overcome this problem by combining specifications with query object pattern. However, you will most likely end up finding yourself sinking into quicksand, parsing all available combinations of your specification which essentially means implementing a mechanism very similar to expression trees on your own. Luckily, we don't have to do this because Microsoft has already gave us the technology. So we only need to build a tiny wrapper on top of the original expression, funct bool type, and add Boolean support, so this code will compile. It's not only solve the original problem, but also improve the readability and reusability of our code, which is nice. So let's take a closer look at the implementation. Here's how the operators are defined in the wrapper. There is just one little thing to do. Unfortunately, these methods just don't exist, but we can fix that by writing some extension methods. So let's write some code. And now we are at the point when you can open your favorite IDE if you like. I'll be sharing my screen and talk you through the code. So you can follow me here or using your setup. Either approach works for me. So the naive implementation would look like this. I started with this one. So here's the expression, here's the another one, and expression dot or else looks like a good starting point. And yeah, maybe this would work. I don't know. So that was my thoughts. Actually, what we have here, this implementation will fail with invalid operation exception. Let's check that. So you see this on the screen. Okay, let's check another implementation. So the problem was that I was trying to combine lambda expressions. So lambda essentially is a body and parameters. So argument exception is trying to tell us that it just makes no sense to combine two lambdas together. Instead of trying to combine lambda, let's try to combine lambda's bodies. And this is something which is closer to the actual implementation, but still fails, but with another exception, which is system argument exception. And don't trust me, let's verify that. And the exception would be incorrect number of parameters supplied for lambda declaration. So now you can trust me. Well, that was kind of disappointing because you cannot easily find the official documentation how to do this properly. So instead of following the official documentation, I had to search on the internet looking for answers. And luckily, I found one. Joseph Albahari is famous for being the author of C# in a Nutshell book. And he's also the author of LINQ software and LINQ kit library that uses LINQ kit internally. Joseph needed to solve the same issue for LINQ kit. So he suggested using expression invoke to fix the issue, and this approach worked for me, at least partially. The combined expression works as expected when applied to in-memory queryables, or when compiled into Delegate. It also works fine with Entity Framework Core, but not with Entity Framework 6. And Entity Framework 6 will throw not supported exception once you try to pass the expression that combines at least one instance of expression invoke in the expression tree. So why? That's a good question. Let's review the let's first examine the official documentation. Here's what I found in the official documentation. I think that you have already read this from the screen. So does it make sense to you? No? Okay, here is the explanation from Joseph. Any better now? Actually, it doesn't matter, because the original goal was to be able to combine the expressions as if we wrote them by hand. So Joseph recommends fixing this problem using a special as expandable method. And I won't go to the technical details of this method here. That's too tedious and boring. Furthermore, there is another method for achieving the same result, which creates exactly the same expression tree as if we wrote by hand. I borrowed this implementation from the blog post by Pete Montgomery, who in turn claims that it was Colin Meek EF team who introduced that technique to him. So let's get back to code. So first, let's examine the implementation of Joseph Al-Bahari. So let's take a look. That's the first expression, which is x less than 1 or else x greater than 3. And another one. I'm not sure if you can see the text here. Let me try to. All right. So, okay. So here is invoke, which would never happen here if we build this expression by hand. And here is the original expressions. So there is no invoke here. What Pete Montgomery suggests to do is a little bit trickier. What we need here is a way to compose expressions with parameters, and the exception was due to the parameters was binded to the body of the previous expression. And what we need to rebind all the parameters from one expression to another. So here is the tricky part. We take first expression, we take the second expression, and we take the function that will merge those expressions. In our case, that's or else expression. We create a dictionary to map all the parameters. And now for the second body, we replace all the parameters with the parameters of the first expression, which parameter rebinder replace parameter method will do for us. And once those parameters are rebinded from expression 1 to expression 2, we can create lambdas, which would look like exactly if as we wrote them by hand. And let's check this as well. So here was implementation by Joseph Albahari. So let's check this. So this works, which means that these two implementations, this one and another one, oh, that's my previous debug session. So these two will be exactly the same. This technique not only makes it possible to combine predicates with or and not statements, but also unlocks some more advanced tricks. Let's say we have a specification for a product, and we have a specification for a category or product group, if you will. So we would like to sort all the categories and put ones that have a good enough rating on top. What if I need to reuse the specification that is originally defined for the category class or products? Still, I cannot do this again because of the type mismatch, unless I call select many instead of select. But what if I don't want to? What if I'm under certain circumstances when I only have a queryable product? What we have here is a lambda that takes category as an input and produces Boolean value as a result. We need a lambda that takes product as input and produces Boolean as a result. So in order to use the existing specification, we only need another expression that takes product and returns category. Once combined, we've got exactly what we need. Those of you who are familiar with functional programming might notice that this might somehow remind you what functional composition is. For those who are not familiar with functional programming, I highly recommend watching Power of Composition talk by Scott Flashin. Scott has already given this talk today, but I think that you can find this video on YouTube as well. So we are finally at the point when the true power of expression trees is revealed. Once we figured out how to combine expressions of any kind, it's clear that this is a powerful code generation tool, which is still much easier to use than the things like reflection emit. Number two, some expression might be easily written, compiled into delegates, and cached. And number three, other ones can be dynamically built in runtime and later combined or not with some expressions that are written by human beings. That's metaprogramming time. So the first good example of using expressions accompanied by reflection is Automapper. So let's take a look. So let's say we have products, and what we used to write is a boring code with handwritten selects. If I have a DTO and I have almost the same properties in this DTO, I have to write tedious and boring mapping code. Things like this are kind of obvious if a DTO has the category name property, that it's obvious that it should be mapped to category name, a property of the original entity. So this how product list DTO looks like. Category name here, and the original entity is here. So yeah, that's obvious. Product.category.name. So instead of writing this boring code by hand, we can use Automapper project to method, which will kindly build all these mappings automatically based on conventions. But what if I told you that we can do the same trick with filtering and sorting? Basically, that is how system link dynamic core works under the hood. So let me run the web app. So let's see. Here is my very simple minimalistic e-commerce solution. And I have some laptops here, some smartphones. What if I'm interested in Apple MacBooks only here? That's fine. Okay. What if I would like to find something else? That's fine. Filtering is working. Also, maybe I would like to sort by name, or sometimes I'd like to sort by price. The sorting also works. So you might be thinking that there is a boring code like if filter is set, then add where statement, blah, blah, blah. No, it works like this. So let me remove this commanded code for now. I have a product filter class, a simple one that has name and price. And my product class also has name and price property. So this means that if product filter name property is set, or price product filter dot price property is set, we can build this filter automatically, and that's what I do. So I need to write just one liner here, and spec builder is a helper class that we commonly use in our production code. So it automatically searches for the same properties by conventions, then caches the filter query, and I have overridden the implicit operator for the specification that is built by spec builder. So I can use the specification instance as a parameter to where method. So no more boring filtering code. The same stuff for ordering. This is a little bit tricky because order by method is not the only one. We have order by and order by descending, and we have two generics there. So the implementation is a little bit more difficult. I'll just show you sources to give you a general idea, but I wouldn't go into technical details because, well, it's more like writing some boring code once in order to avoid writing boring code all the time. So let's get back to the presentation. Actually, that was a simple one. We can do some crazy things. For instance, data validation is a very common task that can be simplified. Long time ago, when we were younger and there was no React, Angular, Vue, and dozens of other JavaScript frameworks, we used to write validation logic once on the backend. And welcome to brand new world. No one uses server-side rendering anymore. Web is SPI-centric now. So now we have to write validation logic twice, one on the backend and the other one on the front end. But we didn't have to. JavaScript developers use Babel to transpile JavaScript code to another JavaScript code, or JS6 to JavaScript, or TypeScript to JavaScript, anything to JavaScript, I have a better idea. What if we just generated it from C# instead of writing it? So luckily, there are libraries, JavaScript libraries, to build web forms with built-in validation support. So let's try to take advantage of it. Here are some examples. This is a screenshot from t-comp form project on GitHub. Take a look at var predicate. Predicate equals function, which returns x greater or equals 0. Looks like an expression, right? Then this is ngx formally, a form builder for Angular. And what we see here, validators, IP, well, these are expressions. We only need to build exactly the same expressions from the C# code and transfer them somehow to the front end. We can even include this meta information into the Swagger definitions if we want to make sure that some essential information is communicated to the front end as a part of type definitions. And let's get back to the code now. So I'll open my example, which uses tcomp under the hood. Okay, let's go here. And I'll click on save. And now I see that price must be greater than 100. So when I click here, what you might not have seen is that there is a server request which gets the error message and the predicate from the server. So back here, what I do here is when component.didMount function is called, and that's the best way to do web request in React. We do a AJAX request to API/form method of our controller and get the JSON file. Then we build this refinement from data that is transferred from the backend. And this data is C# expression that I translated to, well, in this particular example, to string, but we can also translate it to perfectly valid JavaScript. And in this specific example, in this specific case, string actually works for us because what we get is a valid JavaScript. The translation would be exactly the same. So I borrowed this implementation from the existing expression.toString method, which is basically an expression visitor. It's quite complicated to transpile all kinds of C# code to all kinds of JavaScript code, and I don't think that that's even possible because these are just different languages and they're basically too different. So there are subsets of code that cannot be translated to JavaScript. But what we can do, we can create a reasonable subset of the expressions that we would like to support in our application. And then, for instance, we can define a validation attribute and decorate our code with this kind of validation attribute that will include validation logic, which is defined as expressions from our type to bool. Then these expressions can be transferred to JavaScript, and we don't have to write any JavaScript validation on our own because this JavaScript will be generated for us. All right. So what about tests? I've got some more weird scenarios where expression trees might be helpful. You might be familiar with mocking frameworks like MockU. What you might not notice is that how MockU builds mocks internally. Now you're looking at screenshot from the MockU documentation. These lines of code are not delegates. These are expressions. So MockU actually analyzes the expression trees, and uses castle.dynamic proxy internally to compile classes in runtime. So the code that you write in the setup will never run. An expression visitor will walk through the tree and create a class that is actually will be created. So this is a tree that's not the code that being invoked. I realized that this trick might be abused even harder. I don't have a live demo for that, but just let me know if you want to go to some technical details. What we can do is to build a method that takes any controller from our solution and which takes a controller method as a parameter, provided that this parameter is an expression and not delegate. So by passing this expression into some special function, we can analyze the invocation of the controller method and instead of instantiating the original controller, we can build a web request. So that's how we can write integration tests that actually do web requests to our API, but we can use our source code, including DTO files, including controllers, including IntelliSense. So we would write a code that looks like a call of a method of the controller. But what would actually happen is that we would provide an expression tree to the method. Then this method will be analyzed. And once it's analyzed, we build a web request, and this web request goes to the server and get back, and everything is being analyzed under the hood. So this idea somehow is related to computation expressions in F#, if you know what I mean. So anyway, this is a complex topic. So if you have some additional questions, please let me know and just ask me, and we can discuss the details. Well, last but not least, this is a topic that we actively discussed with Vagif Abilov. You might know him as a musician and NDC speaker. We together with him and with Dylan Beatty and some other great guys perform gigs at conferences from time to time, and I hope that we could have done a great gig here at NDC this year. Well, you know, maybe next time. So I'm feeling lucky about it. Anyway, Vagif told me that he has been under impression that rule engine that comes with Microsoft Windows Workflow Foundation is slow, very slow. So he and his team used it to execute some of their business rules, and soon they found out that rule processing slows down the entire application execution. That was really strange. It was hard to believe that industry strength rule engine like this needs a long time to process that, because these business rules were quite simple. So eventually they ran a profiler, and it immediately showed that the time was spent in just one place. In fact, it was not the actual rule validation, but preparation for it. Instantiation of the WF rule parser. The parser class is not public, so they used a trick to obtain its instance. They retrieved its non-public constructor information via reflection and then called invoke. And it was so slow that they noticed it even in their integration tests. So what they did is they took their constructor information, compiled expression invocation, into delegates, cache them, and use them instead of activator create instance. You can see some benchmarks here. So activator and constructor invoke, and the difference is huge when we use parameterized constructor. So here's the clue. You can use compiled expression instead of reflection. Of course, I don't really mean somebody should completely stop using activator create instance, but there are certain use cases like IC frameworks when it gives clear performance advantage. So let's review the IC framework performance comparison table. Clearly, some of them are faster than others. Is it coincident? I don't think so. And I just know because I examined the implementation of simple injector that under the hood, what they do, they build the composition route, they search for all the dependencies, then they create the constructors, compile them, and that's all. Once compiled, we run delegates, no reflection invoked. No, reflection invocation. I'm sorry. So basically, don't use invoke either. Wrapping up. So what we learned after 3 years of actively using expression trees in real projects. Your team can deliver code much faster and write less code in .NET, JavaScript, TypeScript, and probably any other languages. Then your lead developer has to know some advanced stuff. Number 3, expression.compile can be cached if all expressions are defined as static. And that's why you want to define all or most of your expressions as static. So your code might be shorter, but harder to understand. And that's a trade-off. You need to decide if you want to go into some technical details, some weird stuff, if you can get advantage of it. And that's pretty much, this is it.